Alrighty guys, on this video, you should be on page 13 of your notes, have that out. We're just going to talk about friction here, right? And so make sure when I draw this free body diagram, draw it kind of small, give yourself room. Sorry, there should be more room on this. So you want to write your free body diagram kind of small here and give yourself room over here to do that as well, okay? So what we're going to do right now is, you're on page 13, right? So I'm going to go to here, and then, so we know what friction is by now. It typically opposes motion. So that's what you should write down your notes on page 13, opposes motion. So draw on your notes the free body diagram of a 5 kilogram box moving at a constant speed or velocity, right? With a force applied of 2 newtons to the right. So this is what your free body diagram would draw. This would look like here. Notice I kind of drew them to scale. So if you need to pause the video to watch this, you can, right? So write that down in your notes, please. So where you're going to write that down at, you're going to write this down right here. Okay, you're going to write that down right here. Then after you're done, you can continue the video. So the coefficient of friction, that's that Greek symbol mu. It varies based on the 2 surfaces in contact. So what you should be writing down in your notes is that bold word, 2 surfaces in contact. So there's a video I saw that Deanna showed me that when they do a crime scene investigation of, they actually take that actual tire from the crime and they drag it along the concrete where it can only be done experimentally to calculate this stuff, the mu. There are tables for engineers, but in the real world, you typically have to test this. So mu has no units, so you should write down the word units in your notes, because newtons divided by newtons cancel each other out. So it's a ratio. So the question is, does increased weight change the force of friction between surfaces? The answer is yes. This is why people put sandbags. It increases the weight, it increases the normal force, it increases the friction force, which helps with attraction. Does increased weight change the coefficient of friction between the 2 surfaces, though? The answer is no, because I'm going to show you with the rocket sled activity, right? That rocket sled lab we did, or whatever you want to call that. As the weight increases, so does the normal force, so does the friction. I'm going to actually show that to you in the next little snippet now. So on this one, guys, I'm going to make an unbalanced force here, see how long it takes to respond. As I'm recording it, we have an applied force, we have an unbalanced force. I'm going to go ahead and turn the friction on. Right now I have the friction turned off. So I turn the friction on, right? It's negative 50. But I have an unbalanced force, that's why I'm speeding up to the right, accelerating. So I'm going to add some mass. Click on the number 1 here. I add some gold bars, if you will. So watch what happens to the weight, the normal force, and the friction force. They all go up at the same ratio. That is why the mu, aka the coefficient of friction, does not change. But my friction force does change, my weight does change, and my normal force changes. And notice I'm putting up more snow as I add more mass, right? As my weight increases, my normal force increases, my frictional force increases. And I'm going to reach a point now I'm actually slowing down, if you look at this, because my applied force, the force of the rockets, is less than the frictional force. So I'm slowing down until we're going to reach probably some type of equilibrium here in a moment. Anyway, so yeah, I hope that helps with why the mu does not change. Does increased weight change the coefficient of friction? No, it doesn't. And I just proved that with that video I just showed you. So hopefully that makes sense. So what I want you to do, guys, and this is not the most organized, I do apologize. Their note packet's kind of screwed up. I'll change this. I'm going to remake this video for next year. So if you go back to the very top, and I'm going to calculate mu, the coefficient of friction, for that example. So if we go to our notes, which are, we should have all this filled out, right? Everything here, basically to here. We should have everything filled out. Does increased weight change the coefficient of friction? No. Does increased weight change? Yes. Right? And so I want you to put this, what I'm showing you right now, in these notes right here. So you drew the free body diagram, hopefully right here, right? And now we're going to calculate mu, okay, using that equation. Here we go. So remember, mu, well, I haven't said remember, but this is the equation for mu here. This is mu. is, and I made the absolute value because it doesn't matter if it's negative. We're always going to take the absolute value of it, okay? The frictional force divided by the normal force, okay? Now, the reason the normal force is on bottom, if you don't have a normal force, you divide by 0, and you can't divide by 0. That's why the normal force is on bottom. So if you don't have a normal force, you have nothing down there, 0, and you can't divide by 0. So if I do this, I just take my friction force from that free body diagram, 2, I plug it in here, 49, which is the same here, because it's a balanced force on the y-axis, right? I calculated that by the mass of the box, 5, times little g on Earth is 9.8. That's going to give me -2 divided by 49 positive, because it's going up, that's going left. That's why we take the absolute value, because I don't care if it's negative. I just want this, all I care about is this number here. This is a pretty low mu. All right, so that all should be written down in your notes right here. This will help you with this, okay? This will help you, just gives you an example of that, right? So the last thing we're going to do with this, if mu is 0, there's no friction at all. So 0%, I think of it as a percentage, right? 0% friction. So there's no units with mu because the ends cancel out. If you look at the equation, it is, right? Newtons divided by newtons, they cancel. So the coefficient of friction depends on the nature, the smoothness, of the two surfaces, not on the forces. Again, they talk about perpendicular, which is important as well. Typically, just think of it from 0 to 1, 100% friction, 0% friction. There are some examples that go above that. That's why I put the asterisk right here. So typically when you're working a problem and you get a number that is above, like a huge number like 45, you've messed up, okay? And I'll try to make sure that happens on homework and stuff.
Go, hit it. Oh no, are you serious? No way. Are you serious?